Imagine this. A massive dam holds back billions of tons of water. The power plant is shut down, electricity demand is low. The turbines aren't running, yet suddenly millions of liters of water begin roaring out of the dam. At first glance, it looks like an enormous waste. If no electricity is being generated, why release the water at all? The answer has nothing to do with power. It is about protecting the dam, preventing floods, keeping rivers alive, and sometimes avoiding a disaster that could destroy everything downstream. Most people think a dam has only one job: store water, run turbines, generate electricity. Simple, but in reality, generating electricity is only one responsibility. A modern dam is also a flood control system, a water supply reservoir, an irrigation source, a drinking water provider, an environmental regulator, and above all, a structure that must remain safe under every possible condition. That means sometimes the smartest decision is to release water. Even if not a single watt of electricity is being produced, let's see why. Imagine filling a glass with water. You can keep pouring until eventually it overflows. Now imagine replacing that glass with a reservoir holding billions of cubic meters of water. The same rule still applies. Every reservoir has a maximum safe water level. Engineers called it the maximum operating level or full reservoir level. Above that level, the pressure on the dam increases. The freeboard, the safety distance between the water surface and the top of the dam gets smaller. And if a large storm arrives, the reservoir can fill much faster than expected. That is why operators don't simply wait until the reservoir is full. They carefully manage water levels every day. Sometimes releasing water early is much safer than waiting until it's too late. A reservoir is like a savings account. If it is already full, there is nowhere to put tomorrow's deposit. Here is something many people don't realize. Nature doesn't care whether the power grid needs electricity. Rain keeps failing, snow keeps melting, mountain rivers keep flowing. During the monsoon season, thousands of cubic meters of water can enter the reservoir every second. Imagine the inflow is 5,000 cubic meters per second, but the turbine can only pass 1,500 cubic meters per second. That leaves 3,500 cubic meters every second with no way to go through the power plant. The water level keeps rising. Eventually, operator must open spillway gates, not to generate electricity, but simply because more water is entering the reservoir than the turbines can handle. The spillway becomes the dam emergency escape route. Without it, the reservoir could continue rising until it threatens the safety of the dam itself. Flood management is all about planning ahead. Suppose weather forecast predicts several days of heavy rainfall upstream. If the reservoir is already nearly full, there won't be enough storage to absorb the incoming flood. So operators begin releasing water before the storm even arrives. To someone standing downstream, it may seem strange. It is not even raining here, but the dam is releasing water. What they can't see is that hundreds of kilometers upstream, rivers are already swelling. Satellite images, rain gauges, weather radars, and river monitoring stations are constantly feeding data into the control center. Engineers aren't reacting to today's weather. They are preparing for tomorrow. Now let's look at a completely different reason. Imagine a river below the dam. Fish live there, plants depend on it, farmers pump water from it, cities draw drinking water from it, and if the dam suddenly stopped releasing water, the river could shrink dramatically. So water temperature would rise, oxygen level would fall, fish could die, and wetlands could dry out. The communities downstream would lose a vital water source. That is why many dams maintain what's called an environmental flow. This is the minimum amount of water that must always be released to keep the river healthy. Even if the turbines aren't operating, the river still needs to live. Many people assume that if water must be released, why not simply send all of it through the turbine? The answer is simple. Turbines are designed to operate within a specific flow range. Too little water and they become inefficient. Too much water and they can suffer severe damage from vibration, cavitation, or mechanical stress. Each turbine has a maximum flow capacity, and if the incoming river exceeds that capacity, the extra water must bypass the turbine completely. That is exactly why spillway exists. Think of the turbine as a highway with 4 lanes. If 10 lanes of traffic arrives, the overflow needs another route. That is the spillway. Sometimes the reason is much simpler. The power plant is under maintenance. The generators are being inspected, the turbines are shut down, the intake gates are closed, but the river upstream keeps flowing. Water can't simply stop, so operators release it through spillway. Low-level outlets are bypassed instead. The dam continues safely passing water even when producing zero electricity. This is perhaps the most important reason of all. The greatest danger to a dam isn't usually the water flowing through its gate. It's water flowing over the top. This is called overtopping. And for many dams, it is one of the leading causes of catastrophic failure. If water begins flowing uncontrolled over parts of the dam that weren't designed for it, it can erode concrete foundation, wash away earth embankments, and eventually trigger a complete collapse. That is why engineers would rather release enormous amount of water through controlled spillway. They allow even a small amount to flow over the crest of the dam. Controlled release may look dramatic, but they are actually preventing something far worse. So why do dams release water when they don't need electricity? Because electricity isn't the dam's only job. Sometimes they are preventing floods, sometimes they are making room for incoming storms, sometimes they are protecting fish and entire river ecosystems. Sometimes the turbines are under maintenance, and sometimes they are protecting the dam itself from one of the most dangerous situations imaginable. When you see huge volumes of water pouring from a spillway, it doesn't mean something has gone wrong. Quite the opposite. It usually means the dam is working exactly as it was designed. Quietly balancing power generation, flood control, water supply, environmental protection, and public safety all at the same time. The next time you see dam releasing millions of liters of water without generating electricity, you will know it isn't wasting water. It is performing one of the most important engineering decisions it can make. And that raises another fascinating question. If a dam can safely stop a flood, why do some floods still become disasters?